Welcome back to this series on building a full stack application with React and FastAPI. In the previous episode, we refactored our API logic and created a clean data layer. Now we're adding authentication. We'll implement a login page, connect to our FastAPI Backend, and store a JWT token securely in the browser. By the end, our application will begin to enforce access control. Now, if we jump to VS Code and go to our app.tsx file, as you can see, currently, anyone can view the employee's sales data. In real application, we need to ensure that only authorized users can access data. Authentication is the first step towards secure and professional apps. We'll use JWT tokens provided by our FastAPI backend. If you're wondering where the backend comes from, it's built step by step in my FastAPI Backend series here on this channel. In that series, we designed the data models, we implemented JWT authentication, structured routers, and deployed the API to the Vercel cloud provider. You don't need to complete that backend series to follow along here, but know that the API is already deployed and available. And if you want to understand the backend architecture deeply, I recommend watching that series. Now let's start by creating our login component. To do this, let's go to the VS Code terminal. And then we'll create a new directory under the source directory. So let's go to the source directory. And then we'll create a new folder called components, and then we'll switch to the components folder, then create a new file using the touch command called login.tsx. And if we go under our component here, we'll see our file, empty file right now. So let's add code for our login component. So here is the code for our login component. In this component, basically we're building a form, a login form in React that authenticates a user with a backend API. The form collects a username and password, then sends the credentials to our server and receives a JWT access token if the login is successful. We start by importing a use state from React. This hook allows our component to store and update values such as the username, password, and any login errors. The component receives a prop called onLogin. It's a function passed from the parent component. When the user logs in successfully, we'll call this function and sends the access token back to the parent so the app knows the user is authenticated. Think of it as login succeeded, here's the token. Next, we create 3 pieces of state. Username stores what the user types in the username field. Password stores the password input, and error stores an error message if login fails. If there is no error, the value is null. Next, we go to the handle submit function, and this function runs when the user submits the form. Normally, a form refreshes the page. We prevent that behavior so React can handle the submission, and that's what the prevent default does. Before attempting a login, we clear any previous error messages. Here, we create form data using the URL search params. This format is commonly required by authentication systems like OAuth 2 and many backend frameworks. Now we send the login request to our backend API. This is an environment variable, allowing the front end to connect to different APIs depending on the environment. It could be development, staging, or production. The request is configured as a post request. The header tells the server we're sending a form data, and the body contains the username and the password. If the server responds with an error, like invalid credentials, we throw an exception. But if the login succeeds, the server returns JSON containing an access token. We then call the onLogin function and pass that token to the parent component. The user is now authenticated. If anything fails, incorrect password, network error, or server rejection will display an error message to the user. The form is connected to our handle submit function. When the user clicks the login or presses enter, the request is triggered. The input field updates the user name state every time the user types. The field works the same way, but it hides the characters for security. And the button triggers the form submission. If an error occurs, React displays the error message below the form. If there is no error, nothing is rendered. In about 40 lines of code, we've built a complete authentication flow. Capture user credentials, send them securely to a backend API, receive an access token, and update the application's authentication state. This pattern is the foundation of modern full-stack applications. Now let's update the file that actually talks to our backend API. So let's go to our employee API.ts file. Remember, its job is to fetch employee sales data from the server. So let's update this file here so that it optionally accepts a JWT token. And here are the changes after the update. Let's break it down a bit. At the top, we import the employee type from our types folder. This simply describes the structure of an employee object, like the employee's ID, name, and sales numbers. It helps TypeScript make sure the data we work with is shaped correctly. Next, we create a constant called base URL. This value comes from an environment variable called vt API URL. In other words, instead of hard-coding the API address, we store it in our environment settings. That way we can easily switch between different environments like development or production. Then we define the main function called fetch employees. This function is async because it makes a network request to our API. The function optionally accepts a token. This token is used for authentication, meaning The API can verify that the user is logged in before returning any data. Inside the function, we create a headers object. If a token exists, we add an authorization header using the bearer token format. This is a very common pattern for securing APIs. Next, we send a request to the server using the fetch function. The request goes to the employee's endpoint. In our case, it will be a sales endpoint. And we include the headers we just built. After the request is sent, we check if the response was successful. If the server returns an error, we throw a new error saying failed to fetch employees. This allows the calling component to handle the error properly. Finally, if everything worked, we convert the response into JSON and return the employee sales data. So, in simple terms, this file acts like a small service layer. Instead of putting API calls directly inside our React components, we keep them here in a separate file, and that keeps our code cleaner, easier to maintain, and easier to reuse throughout the app. Now let's go to our app.tsx file, or our main file, and update it to handle JWT. After making the changes, here is the new code. Let's walk through the updates and see how it connects everything together. At the top, we import a few things from React: useState and useEffect. useState lets our components store data, and useEffect lets us run code when something changes. We also import three things from our project. First is the employee type, which describes what an employee objects look like. Then we import fetch employees, which is a function that calls our API to get employee data. And finally, we import the login component we built earlier. Inside our app component, we create three pieces of state. The first is token. This will store the authentication token we get after the user logs in. It starts as null, meaning the user isn't logged in yet. Next is employees, which will store a list of employee objects. It starts as an empty array. And the third is error, which will hold an error message if something goes wrong while loading data. Next, we use useEffect. This hook runs whenever the token changes. Inside the effect, we first check if there's a token. If there isn't one, we stop right there, because that means the user isn't logged in yet. If a token does exist, we run an async function called loadEmployees. This function calls our API using fetch employees, passing in the token so the request is authenticated. If the request succeeds, we store the employee data in a state using setEmployees. But if something fails, we set an error message saying we couldn't load the employee data. Finally, let's look at what gets displayed on the screen. We use a conditional check. If there's no token, we show the login component. When the login succeeds, it calls setToken, which stores the token in our state. Once the token exists, the app switches to the main dashboard view. We display a heading called Employee Sales, show any error messages if they exist, and render a table of employees. Each employee is displayed as a row with their name and their sales numbers. So in simple terms, this app component controls the whole flow. It shows the login page, stores the authentication token, fetches employee data from an API, and displays it in a table once the user is logged in. Now it's time to test the application. To do this, let's go to Terminal, and then we'll run the npm run dev command. And as you can see, the application is now running on localhost 5173 port. So if we jump to our web browser, at our browser, if we go to localhost port 5173, we get, when the page loads, we get our form with the username and password, as well as a login button. Now we have a fake backend user credential called admin, and the password is admin123. And if we click login, this should take us directly to our, let's click this out, to our dashboard, which is the sales data for our employee. And that's basically working as expected. Now let's do the opposite of that, which is if we don't have a proper credential, and see what happens. To demonstrate this, I'll open a new window, and then I'll go to localhost 5173 to get a new login page. Then I'll enter, before we do that, let's inspect this by using developer tools, inspect here, and then we'll go to the console as an example to see what's going on. And then I'll enter admin and then a bad password, anything, and then click on the login. As you can see, I get invalid credential as my error message. But as you can see here in our tool, what's really going on here, I'm doing a post, and here's my endpoint here. And as you can see, I'm getting an unauthorized error, a 401 unauthorized error as expected, because I entered a bad password according to the back end. So that's working as we expected it to. Now, if we return to our working tab, and if we do the same thing here, inspect, and then let's do a refresh, and then re-log in, do admin with the proper password or the working password, then click login. Now, if we investigate this a little bit more, if we go to the network tab and then go to our login form here, you can see the response that we got after we successfully logged in is the access token, which is right here, and the token type, which is bearer. We'll be able to use the access token throughout the app to get all kinds of data. JWT tokens allow secure communication between front-end and back-end. By centralizing token handling in the API layer and app state, we keep components focused and maintainable. Features like protected routes and refresh tokens integrate cleanly. Now let's commit our login functionality and API updates to GitHub. So to do this, let's go to VS Code, and then we'll use the source control tab here, and then we'll put in a message. Let's say what we've done. We added a JWT token, store token in app state, and update our API for auth. And then we'll click commit. And then we'll sync the changes so that the push goes to our GitHub repo. In this episode, we implemented login functionality and JWT token storage. Next, we'll secure pages and only allow authorized users to access specific routes. This is where our app starts feeling like a real professional system. If you haven't already done so, please subscribe so you don't miss out. See you then.